Hello, everybody. All right, so today we're just going to discuss area of combined rectangles. We're on lesson 11.8 on page 483 of the third grade Go Math textbook. So our essential question for that you should be able to answer at the end of the lesson is, how can you break apart a figure to find the area? Well, let's look at the unlock the problem. Anna's rug has side lengths of 4 feet and 9 feet. What is the area of Anna's rug? Okay, so side lengths of 4 feet and 9 feet. What is the area? Well, we know that area, we can count all the square units. We can multiply the sides. We can use repeated addition. So there's a couple of different ways we can do this. So let's draw it first. 9 feet by 4 feet. Let's see, 1, 2, 3, 4. So 4 feet in length, 9 feet in width. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have a 4 by 9 right now. But it says, how can we break apart a figure to find the area? So in other words, we could add up all of these individual squares. But is there an easier way? We could also multiply 4 times 9, which if we know our 4 times tables and our 9 times tables, very easy to do. But what if I don't, or I'm not confident about multiplying by 9s, or I'm not comfortable multiplying those higher numbers? Can I break up the 9 into something smaller that would be easier for me to multiply? Well, could we break the 9 into 5 and 4? We could. So let's try that. 1, 2, 3, 4. Okay, so I'm going to draw a little dividing line there. And so now this square is actually 4 by 4, right? Okay, this piece over here is 4 by 5. 4 plus 5 is 9. So I didn't change the number of squares. I just made them into two smaller math problems. Okay, so this is not the only way you can break up 9. You could have also broken up the 4. You could have made it like 9 times 3 plus a 9 times 1, or a 9 times 2 plus a 9 times 2. Doesn't matter. Okay, so we can play with those numbers and make them smaller into easier math problems. So the side length 9 is broken into, what am I going to break it into? I'm breaking it into 5 plus 4. Somebody else might do 6 and 3, 7 and 2, 8 and 1, as long as it adds up to 9. So find the area of each of the two smaller rectangles. So as I said, my first one, I have 4 times 4. Okay, so that's the area of one of my squares or rectangles. The second rectangle is a 4 by 5. Okay, so 4 times 4, that should be a simpler problem. And again, we're getting so late in our third grade year, we really should know our multiplication tables. Okay, it will make doing fourth grade so much easier if you have these memorized. So again, when we get to 4 times 4, we should be able to quickly say 16. If not, we need to practice. You need to practice and say 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. So on, okay? And it needs to be really quick, okay? It's not something that you should have to think about. So 4 times 4 is 16 square units. 4 times 5 is just one more 4, right? So 20 square units. Now all I have to do is add those two smaller products. So one of the smaller rectangles was 16 square units. The other one was 20 square units. So what's 20 plus 16? 36. Now, would it have been easier just to say 4 times 9 is 36? Yeah, okay, it would be. All right. But this is a strategy for if the number is something that you don't understand. Like, what if this was a double digit number? Well, we haven't talked about that. Like, what if it was 17? Well, we haven't learned how to multiply 17 times 4. But I could break up the 17 into 8 and 9, and I know how to do that. Or I could break up the 17 into 10 plus 7, and I know how to multiply by 10. I should know my 7 timetables. So there are ways we can break these into smaller numbers. And basically what we're doing there is using the distributive property. Okay, we're taking a larger number, breaking it up into two smaller numbers, and multiplying by the other factor. All right, so 36 square feet. Okay, so the area of her rug is 36 square feet. All right, page 484. So connect. So again, see, it says using the distributive property, you found that you could break apart a rectangle into smaller rectangles and add the area of each smaller rectangle to find the total area. How can you break apart this figure into rectangles to find its area? So how could I split this one? Well, one way, I could just go ahead and cut it into one large rectangle going this way and this smaller one down here. I could also split it vertically and have this be my long rectangle and this be the smaller rectangle. It doesn't matter. We're just making it into something a little simpler to do. So we're going to call this rectangle 1 and we'll call this rectangle 2. So write a multiplication equation for each rectangle. All right, so remember it's rows by how much is in each row. So 1, 2, 3. I have 3 rows, and in each row I have 1, 2, 3, 4, 5, 6, 7. So I have a 3 by 7 rectangle. If I really can't figure out what 7 times 3 is, you should be able to do 7 times 3. Okay? We should be able to get there by skip counting, if nothing else. You could put 1, 2, 3, 4, 5. You could count each of those squares. Okay? But we shouldn't have to. We should be able to do 3 times 7. 7 plus 7 is 14. 14 plus 7, 21. So 21 square units. And the bottom one, rectangle 2, 1, 2, 3, a row of 3 rows, and in each row there are 3. So our second one is a 3 by 3, and 3 times 3 is 9. So then we're going to take those two products, the 21 and the 9, we're going to add them together. What is 21 plus 9? 9 plus 1 is 10. We need to regroup as 1 10 and 0 ones. 2 10s plus the regroup 10 gives me 3 10s. So 30 square units. Now, just to re-illustrate the idea of distributive property, so this problem originally, if we did it all, the number being broken up into something smaller is really the 3. The 3's here, because really we're just doing 6. 6 times 3 plus 6 times 7. Okay. All right. Another way, we could go vertically. All right. So we'll call this rectangle 1, that rectangle 2. Does it matter which one you call 1 and 2? No. Okay. How many rows? 1, 2, 3, 4, 5, 6 rows of what? 1, 2, 3. 6 rows of 3. Rectangle 2, 1, 2, 3 rows. And how much is in each row? 1, 2, 3, 4. So we have 4, I'm sorry, 3 times 4. So 6 times 3, we should be able to do that. I know that 6 times 2 is 12, and 6 more is 18. So 18 square units plus 3 times 4, that's 12 square units. And now all I have to do is just add them up again. So 18 plus 12. Well, 8 ones plus 2 ones is 10 ones. I'll regroup that as 110 and 0 ones. 110 plus 110 is 2 tens, plus the regroup 10 is 30, or 3 tens. Okay, so a couple ways, all right? I kind of actually like doing the combined rectangles. I think it's kind of fun to break them up into smaller parts. All right, rectangle 1. Draw a line to break the figure into rectangles. Find the total area of the figure. So again, remember, there's going to be 2 ways we could do this, okay? I could break it vertically like that, okay? If I did that, if I called that rectangle 1 and that rectangle 2, it would be a 2 by 4 and a 1, 2, 3, 4 by 3. So then I would write in my numbers as 2 times 4 is 8, and 4 times 3 as 12. And I would add 8 and 12. 12 plus 8 is 10. Regroup that as 110 and 0 ones. 1 and 1 is 2 tens. So I'd get 20. Okay, but I could also go this way. Okay, so some of you might want to go that way instead. And in that case, we would have had 2 rows of 3. And so this area would be 6 square units. And the bottom would be 2 by 2, 4, 6, 7. And 2 times 7 would be 14. But 14 plus 6 is still 20. Okay, so it doesn't matter how you break them apart. Okay, just make sure you have rectangles. Okay, where opposite sides are equal. So you have 2 pairs of opposite sides that are equal. Okay. All right, let's try some more. So number 2, use the distributive property to find the area. Show your multiplication and addition equations. So let's figure this out as far as what is it originally without breaking it apart. 1, 2, 3, 4 rows of 1, 2, 3, 4, 5, 6, 7. 4 by 7. You know what? I think I want to break up the 4. And so I'm going to go that way. And so now I have 2 times 7 and 2 times 7. Okay, so what I did was I split my larger rectangle into 2 by 7 rectangles. Okay. So 2 times 7 plus 2 times 7. So we call this rectangle 1 and rectangle 2. 2 times 7 is 14. So what is 14 plus 14? 4 and 4 is 8. 110 plus 110 is 2 tenths. So we get 28 square units. Is that the only way I could have broke that rectangle apart? No. You could have broken the 7 apart if you wanted. And it's something like 4 times 5 plus 4 times 2. There's so many different ways you could break that apart. Okay. Number 3. 1, 2, 3, 4, 5. I like multiplying by 5. Easy. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, maybe I don't like to divide by 9. I mean, multiply by 9. I do, but let's say I don't. I do like to multiply 5 times 5. So let's break apart the 9 into 5s and 4s. 1, 2, 3, 4, 5. So this rectangle here is now a 5 by 5. And I'm going to call this rectangle 1. Rectangle 2 in rectangle 2, we have 1, 2, 3, 4, 5, and 1, 2, 3, 4. All right, so rectangle 2 is a 5 by 4. And 5 and 4 is 9. So what I did was I broke up the 9 and multiplying the add-ins of 9 with a 5. So rectangle 1, 5 times 5. Rectangle 2, 5 times 4. All right, well, 5 times 5 is 25, and 5 times 4 is 20. Now we're just going to add them together. So the area of this one is 25. The area of this one is 20. Add them all together. 5 and 0 is 5. 2 tens and 2 tens is 4. 45. And I know that that's reasonable because 5 times 9 is 45. All right, number 4. Use the distributive property to find the area. Show your multiplication and addition equations. So don't make that the word distributive property scary. It basically means take one of the add-ins and make it into a smaller number and multiply. So this is a 3. That's not a bad factor, right? 3 is pretty nice. 1, 2, 3, 4, 5, 6, 7, 8. What are some ways we could break up 8 into making it into a nice number to multiply? How about 3 times 4 twice? 1, 2, 3, 4. I divide it this way. Right? So I split it into 2 rectangles of 3 by 4. Okay, so rectangle 1, rectangle 2. So rectangle 1, we're going to say is 3 by 4. So 3 times 4. Rectangle 2, 3 times 4. So 3 times 4 plus 3 times 4 is the same as 3 times 8. So 3 times 4 is 12. So 12 plus 12. 12 plus 12. 2 plus 2 is 4. 110 plus 110 is 2. So 24 square units. Oh, they gave me the answer right there. Okay. All right, number 5. 1, 2, 3, 4. 4 rows. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ooh. I got to tell you, there's in my mind, there's no reason I would break that up. Okay, that's a very easy problem, 4 times 10. But because we are practicing using the distributive property to find area and breaking larger rectangles into smaller rectangles, we'll go ahead and do that. I'm going to go ahead and break the 4. Okay, could you break the 10 apart? Sure. Okay, so I'm making 2 2x10s. Okay, so 2 times 10, 2 times 10. Again, I took one large rectangle and broke it into 2 rectangles. So I have 2 times 10 for rectangle 1, rectangle 2, 2 times 10. 2 times 10 is 20, 2 times 10 is 20, 20 plus 20. I should be able to do that one in my head, but I will go ahead and stack it and do the problem. 0, 0 ones. 2 tens plus 2 tenths is 4 tenths. 40 square units, right? 4 times 10, that's 40. So in the real world, I would not have broken that apart, okay? But since they want us to practice it, okay, we'll play along. I could have also broken up the 10 and made it 4 times 5 plus 4 times 5. That would have been easy. All right, number 6. Draw a line to break apart the figure into rectangles. Find the area of the figure. Okay, so remember, we can go this way or this way. I'm going to choose to break it apart that way. So on this side of the dashed line, I have a 1, 2, 3, 4 by 3. I'm going to make that rectangle 1. In rectangle 2, I have 2 rows of 1, 2, 3, 4, 5, 6. So I have 2 rows of 6. Why isn't it 2 rows of 9? Because I'm using these 2 rows as part of this rectangle. Okay? So that's why the line's important. Don't go past the line when you're setting up your rectangles, your dimensions. All right, so rectangle 1 we said was 4 by 3. Rectangle 2 is 2 by 6. So 4 times 3, 12. 2 times 6, 12. What's 12 plus 12? 2 ones plus 2 ones is 4 ones. 110 plus 110 is 2 tens. 24 square units. Number 7. So this one's kind of an interesting one. Look, we have 3 rectangles. Do you see the 3 rectangles? Yeah, right down the middle, right? There's 1, 2, 3. So 3 rectangles. So we have 4 rows of 3. I'm going to call this one rectangle 1. I'm going to call this one rectangle 2. And the last one rectangle 3. So rectangle 2, there are 2 rows of 3. 2 rows of 3. And rectangle 3 is the same as rectangle 1, 4 by 3. So rectangle 1, 4 times 3. Rectangle 2, 2 by 3. Rectangle 3, 4 by 3. Okay, what's the product of 4 times 3? 12. What's the product of 2 and 3? 6. What's the product of 4 and 3? 12. So we're going to go 12 plus 6 plus 12. Does it matter which order I add those? No. So I'm actually going to flip those around and go 12 plus 12 plus 6. 12 plus 12 is 24. 24 plus 6. 6 and 4 is 10. Regroup that as 110. We get 30 square units. If you wanted to check whether you broke this apart right and did the smaller rectangles right, you could count all of those squares. I should get 30 squares if I counted them all up. Okay, so that's a way of double checking your work. All right, number 8. A model of Ms. Lee's classroom is at the right. Each unit square is 1 square foot. Draw a line to break apart the figure into rectangles. What is the total area of Miss Lee's classroom? Okay, I could go this way or I could go this way. I think I'm going to go this way to have a smaller side. So this rectangle 1 is 1, 2, 3, 4 rows. 4 rows of 9. This one is 1, 2, 3, 4, 5, 6, 7 rows of 1, 2, 3, 4, 5, 6. 7 rows of 6. So rectangle 1, 4 times 9. Rectangle 2 is 7 times 6. 4 times 9, that's the same as 2 times 9 plus 2 times 9. In other words, 9 times 2 doubled. 9 times 2 is 18. 18 plus 18 is 36. So 4 times 9 is 36 square units. 7 times 6. Well, I know 7 times 5 is 35. If I add 7 more to that, 35, 40, 42 square units. So 42 plus 36 gives me 78 square units. So number 8, 78 square units. Number 9, David has a rectangular bedroom with a rectangular closet. Each unit square is 1 foot. It's 1 square foot. Draw a line to break apart the figure into rectangles. What is the total area of David's bedroom? I don't know. Sake of variety. Let's go the other way. Okay. So I'm going to call this top one rectangle 1 and the bottom one rectangle 2. Could you have gone vertically again? Sure. Okay. Doesn't matter. All right, rectangle 1. Rectangle 2. Rectangle 1 is a 2 by 1, 2, 3, 4, 5. 2 times 5. That's easy, right? 2 times 5, 10. 10 square units. Rectangle 2 is 1, 2, 3, 4 rows of 1, 2, 3, 4, 5, 6, 7, 8, 9. 4 times 9. Well, I just did 4 times 9. Might as well use what I've got. 4 times 9, 36. Now we're gonna add those together. 10 plus 36 equals what? 36 plus 10 is 46. 46 square feet. I should have circled 1 square foot. So the measurement was 1 square foot. What is the total area? 46 square feet. And number 10, explain how to break apart the figure to find its area. Well, wouldn't we break it into 3 rectangles? Okay, so break it into 3 smaller rectangles. Rectangle 1 is 1, 2, 3, 4, 5, 6 by 3. Rectangle 2 is 3 by 1, 2, 3, 4, 5. 3 times 5. Rectangle 1 is 6 by 3. Rectangle 2 is 3 by 5. And rectangle 3 is 1, 2, 3, 4, 5, 6, 7 rows of 3. 7 times 3. So 6 times 3 is 18. 3 sets of 5 is 15. And 7 times 3 is 21. Okay, that is how easy it should be to multiply. Okay, those basic math facts. Just 7 times 3 is 21. All right, so we would add those all up. 18 plus 15 plus 21. 18 and 15, 8 and 5 is 13. Regroup that as 110 and 3 ones. 2 tens plus the regroup 10, 3 tens. So we get 33 plus 21. 33 plus 21. 3 and 1 is 4. 3 tens and 2 tens is 5. So 54 square meters. How do I know it's 54 square meters? Because it tells me each square is 1 square meter. Okay. And number 11, use the distributive property to find the area of the figure at the right. Write your multiplication and addition equations. Okay. So let's see how 1, 2, 3, 4, 5, right? I don't think I want to change the 5, but let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yeah, I don't want to change the 5. I'm actually going to, some people may immediately say, well, I'm just going to do 5 times 6 twice. You could. But I actually want to do that. I want to do 5 by 10 and a 5 by 2. So rectangle 1, rectangle 2. So rectangle 1 is a 5 by 10. Rectangle 2 is 5 times 2. 5 times 10, easy, 50. 5 times 2, 10. 50 plus 10, 60 square centimeters. Okay. Each unit is 1 square centimeter. And number 12, Pete drew a diagram of his backyard on grid paper. Each unit square is 1 square meter. The area surrounding the patio is grass. How much more of the backyard is grass than patio? Show your work. So we basically have a subtraction problem here. Okay, we need to figure out the area of the grass versus the area of the patio. So if I take the grass, I can break that into 3 different rectangles. Okay. And I'm just going to put 1, 2, 3. Okay, rectangle 1. 1, 2, 3, 4, 5 by 2. Rectangle 2. Rectangle 2 is 3 by 2. 3 rows of 2. And rectangle 3 is the same as rectangle 1. 5 by 2. All right, so rectangle 1 has a square area of 10. 10 square meters. 3 times 2 is 6. And 5 times 2 is 10. So we're going to go 10 plus 6 plus 10. 10 plus 10 is 20. 20 plus 6 is 26. So the grass is 26 square meters. What's the patio? The patio, it's just quick to just add them up. That's 4, right? 4. So 26 take away 4. 22. There are 22 more square meters of grass than there are patio. Should I check to see if there's actually 30 squares? Well, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 5 times 6 is 30. All right. But I don't have 30 square units of grass. 4 of them are the patio. So that's where I get the 26 from. 26 take away 4 gives me 22. 22 more square units of grass than patio. All right. So that's it for how to use combined rectangles to find the area. In our next lesson, we're going to be talking about figures that have the same perimeter but different areas. Okay, so until then, may the numbers always be in your favor.